Good morning, everyone. Welcome to the latest NTT ICT webinar. My name is Philip Saunders. I'm a Senior Technical Architect as part of the Professional Services Group within NTT ICT. And today's talk is about all-flash storage. What you need to know about it, how you can best use it, and tips and tricks on what to look out for if you're going to look at a flash storage environment for your organization. Hoping that you can all hear me there. If you have any problems or want to ask a question, you can look into the chat section and post your questions in chat. I will be more than happy to answer those questions at the end of the talk. If there's any communications problems, please let us know in the chat section as well, and we'll try to address them as we go along. So with that, I will begin the session. So what we'll cover in the next 45 minutes to an hour is a little introduction if you're not aware of who NTT ICT are and what we do. A little introduction about myself. Then we'll get into what is actually all-flash storage and who are the players in this space. Some of them you all know and love. Others you may not have heard of before, so it's good to know who they are. Also, understanding what is flash, why it's good, how you can best use it, what the differences are between some of the new all-flash storage players in the market space and what some of the traditional tiered storage vendors are doing in this space as well. And finally then we'll look at some tips and tricks, what to look for, a use case scenario around what would be a good use for flash in your environment, and how NTT ICT as an independent organization can help you in finding the right solution that best fits what your business needs are. And then we'll go into a Q&A. So with that, just a quick intro for those of you who are not fully aware of what NTT is all about. NTT is itself a global IT and telecommunications company. NTT Communications, where myself is part of, is one part of that organization, and we focus on delivering infrastructure, network, cloud and security services at a very high quality and risk-sensitive customers, especially in enterprise and government organizations across Australia and New Zealand. From a local perspective, outside of what NTT corporate do, we have over 200 specialist staff here in Australia, supporting over 1,000 customers. We have a full local 24/7 engineering and support team, supporting operations in 6 data centers across the country so that we can support data sovereignty requirements for our customers. We have a couple of warehouses that manage logistics for our infrastructure business. And most importantly, we have full local decision-making capabilities here within Australia and New Zealand so that we can operate quickly around organising solutions that fit your needs. At a global level, NTT corporate has over 200,000 staff operating in 69 countries. We are the second largest provider of data center space in the world and the second largest internet backbone provider by IP addresses connected. We invest over $3.5 billion in R&D annually. And on top of that, we provide a large private, hybrid and public cloud services that is, along with NTT Data, the 5th largest global SI, and if you combine Dimension Data as well, which is a large system integrated with public cloud also here in Australia. Most people will know NTT as a Japanese mobile phone provider, which is NTT Docomo, and if you wanted to be the equivalent of that, that would be Telstra here in Australia. We also are an industry leader in next-gen mobile services, but not only that, we help fund the i3 Institute, which is an independent research institute in the heart of Silicon Valley, developing new technologies around mobile and telecommunications. So with that out of the way, why should you listen to this particular talk? Well, and me in particular. Well, I've been working in IT for just over 20 years now, in various roles, including with ISPs, working with vendors, in universities. I've spent over 14 years working in the storage and data protection space, as well as working as a storage consultant with HP and EMC for a bit over 11 years. I have a number of storage certifications across a number of vendors, and I'm a long-standing member of the System Administrators Guild of Australia, and I'm currently serving as the National Returning Officer. So I have a vested interest in promoting good practices and ethics across IT as a whole. But most importantly right now for yourselves is that now that I no longer work for any of the vendors, I can speak freely because I no longer have the the mind control chips in the back of my head. So I can give you independent and honest advice about what will be best for your organization. With that out of the way, let's talk about flash storage. Now, there's a particular reason I'm using this imagery here of poor old Wile E. Coyote chasing the Roadrunner, and in this particular instance, him using a rocket. So rocket is flash storage. It's extremely fast. It's much faster than the actual Roadrunner itself. Now, the reason I've used this particular imagery here is that while Wile E. Coyote's thought processes and his desires are genuine and on the money, his execution in using those plans to actually achieve his goals don't always come off correctly. And if you look at this case, he's sitting on the rocket, he's actually standing on the tip of the rocket with the fork and spoon, ready to devour his prey, not realizing that the Roadrunner can do a deviation left or right, and then kapow, he runs into a brick wall. This could be the same thing that could happen to you if you just blindly go into the flash storage space, spend a lot of money on buying some really fast storage to serve your applications, but you don't get the real benefit out of it. And the reason for that is not knowing what your I/O profile is like for your actual application. So understanding your I/O profile is key so that you know what you're trying to do and what you're trying to achieve, and then you can spend the money wisely on what would be the best outcome for your environment and your business. Now, there's a number of players in what I like to call the Sandpit. Most of them you all know, love, or loathe. HP, Hitachi, EMC, Oracle. These are the traditional storage players that have been around for quite a long time. But with the advent of flash storage, there are a number of new players on the block. And you might not have heard of some of these. Pure Storage, Violin Memory, SolidFire, Nimble. These are just a few of the new guys that have come onto the scene in the last 3 to 5 years. And they're making a mark in the marketplace. And some of them are using some very innovative technologies. Some of them might be flashes in the pan. Others will actually be here for the longer term because they've actually done a very good strategy around how they're trying to position flash storage and how they use it to new and their existing customers. So it's good to know who they are and what they're trying to do for you. Now, we all know and love Gartner and how they view the market space. So we all know that in the traditional storage array market, everybody is sort of piled into different quadrants. based on their ability to execute and their completeness of vision. So you'll see all the major storage players are up and around in the leaders and challengers quadrant, and some of the new guys, such as, for example, Nimble, are getting into that leaders space or moving in that particular direction. So there's a number of players here, but what you might notice over in the all-flash storage market is there might be a few names missing, and that's because of the definition of what Gartner calls an all-flash storage market space, and that is specifically this vendor has a product that is all flash storage only, so there's no spinning metal disks on offer for that particular model of storage array. So that's why you will see players such as Pure Storage with their Flash Array M series, you'll see EMC with their Extreme IO, IBM, HP, SolidFire, Violin Memory. They're all in the all-flash Magic Quadrant because they have a specific model around that. But there are a few providers that are there that are not in that particular Magic Quadrant because of the way they use their flash technologies. Nimble Storage is a perfect example of that, is that they use their flash storage in combination with high capacity drives in order to provide fast IOs but at the same time a large amount of capacity. So it's good to know the subtle differences between what each of the vendors are bringing to the market space so you can make an informed decision about what's best for your organization. So, first things first, let's get down to basics. What is actually flash storage? So, look at it as, we all understand that we have flash memory keys, that have been floating around for a while, compact flash cards that are going to cameras, the flash memory that goes into your mobile phones. What they actually are just digital floating gates, as we call them. So originally when flash memory was designed, it was basically based around what was called the NOR gate design, which is individual cell connections along a bus line. This design originally extremely fast, but was very expensive to actually construct and manufacture. So over the course of time, the manufacturers came up with a second design that was primarily based on NOR gates, but actually grouped cells together, and this is called the NAND design or NAND gates. And typically these are pages of cells that are grouped together along a bus line. So you would have a single connection coming into this particular group of cells, and then that would be where everything would be stored using ones in electrical charges to open or close the gates, so to speak. Now, this is a lot cheaper compared to a NOR gate, and still provided a quantum leap in speed from a traditional hard drive. So, obviously, cheaper, still providing the same benefits. That's where things started progressing from a commercial aspect, and that's where most of the memory cells today are based on NAND gates. So what do you actually get from an actual flash drive, now that you understand what the basics of the actual technology is? So most of the flash storage vendors and traditional storage vendors use either what's called a single layer cell module or a multi-layer cell module. Multi-layer cell, when it was originally designed, was actually just 2 layers. So what that is just a single layer cell is actually 1 bit per cell, where you have an individual group of flash gates and just 1 layer of those cells, 1 layer of silicon. Multi-layer cells have dual layers. Now there's 2 types of those MLC drives. There's the CMLC, which is known as consumer multi-layer cells, or EMLC, which is enterprise. And the difference between the two is that in the eMLC drives, the enterprise ones, they provide additional error checking modules so that they can protect the data that's written to them. They're a lot more expensive, but they don't suffer from the same level of failure rates that a consumer level drive would potentially come up against. Now, you'll notice that over the course of the last 12 months, the size of flash memory drives, so to speak, or flash memory modules, has grown quite significantly in the last 12 months or so. So you're now starting to see companies like HP and Dell and most of the storage providers are now coming out with multi-terabyte flash drives. Some are still using SLC flash memory module designs. Others are using MLC or a variant thereof. What you're going to start seeing more of over the coming years is triple layer cells or TLCs. Some marketing folk like to call them 3D MLCs because 3D is a good marketing buzzword. And you'll also see quad layer cells or QLCs. So it's interesting to note that a couple of weeks ago Toshiba announced that they will be mass producing a 47 layer TLC memory module design that can scale up to 128 terabytes. That's quite massive. So the concept of having to buy lots of smaller sized memory modules for your storage arrays for flash, this is going to start becoming a much bigger exercise. It'll be much easier to get to petabytes in scale. Again, the cost of those is going to be rather expensive at the start, but when you start looking at what the possibilities are, the sky is very much the limit, and the life of the trusty old spinning metal disk is going to start getting shorter and shorter. QLC flash memory modules, you'll start seeing a lot more of those in the consumer space because you can fit a lot more memory inside the same silicon space. So your iPhones and your Samsungs, you'll start seeing a lot of those devices start using QLC memory designs over the course of the next few years. So what are the benefits of all this? Well, obviously the first one is performance. Running read or writes over silicon speeds is a hell of a lot faster than over a traditional spinning metal disk. But it's good to understand what the actual speed difference is so that you can understand how fast this technology is compared to what you've been used to. So let's look at the differences in the number of IOPS that you would get from the different types of drives. Your high capacity nearline SAS storage drives, they come in at around 70 IOPS per drive, and that's a physical limitation based on the size of the disk platters and the actual motor that spins the platters around inside of the actual drive housing. A standard 10K RPM SAS drive gets around 150 IOPS. The 15K drives, which we don't see much of these days, come in at about 182. Flash memory modules, the average that we design against is around 5,250 IOPS per module, and that's 28 times faster than spinning disk. That's a quantum leap in speed. So it's worth noting that while yes, flash storage is a little bit more expensive than spinning disk at this point in time, the performance benefit that you get from those memory modules is humongous. But like all good IT managers, we're all looking at our budgets and going, is this the best use of our money? So in order to combat that typical one-to-one comparison around the cost of flash storage, some of the new flash storage vendors that have come onto the market space have been promoting other technologies to complement the speed, and that's to give a better value proposition to how you use flash storage, and that along comes around utilization. So those technologies include compression and of course deduplication. Now deduplication is sometimes putting a finger in the air and seeing how strong the wind is blowing in a particular direction, because it depends on the type of data that you're trying to dedupe or compress. Some environments like virtual desktop infrastructure, VDI, they compress and dedupe really well because you've got multiple instances of the same image for a desktop being presented out hundreds or thousands of times. So those dedupe really well. Others may not. Geographical databases sometimes don't dedupe as well as they could. So one of the vendors that's out there, Pure Storage, they actually publish their average deduplication rates across all of their storage arrays that they have out deployed to customers. And they have come out and told us that as it stands right now, they're seeing on their storage arrays deduplication rates of anywhere up to 5.5 to 1. So again, that'll be different depending on what your I/O profile is, and that's why it's really important to understand what your I/O profile is, so that you can see whether or not you can get really good use out of some of these beneficial technologies, not just the raw speed that you get from flash storage. But as I said before, Toshiba are coming out with 128 terabyte flash modules shortly. 2018 they're predicting. So the tipping point of cost versus performance, that one-to-one comparison, is going to start going away, because the actual size and benefit that you can get from flash storage, as more flash storage is adopted across the entire IT landscape, the costs are going to come down, and they're already starting to see the cost versus performance tipping point is starting to get closer and closer to happening. Gartner and IDC both think that tipping point will happen sometime in the next 12 to 18 months. So it will no longer be, I could get by with just having spinning metal disk and a little bit of flash in between. The discussion is going to be more around, right, how much of this flash storage do I need, and do I actually need to have a lower tier to store cold data on? But in the meantime, as it stands right now, there is still that discussion point. So you need to look at what the different vendors are offering and see what's best for your environment now and over the course of the next 3 to 5 or 10 years in some cases. Which brings me to looking at the catalog. What's available? Is it good for my organization? Or are there other beneficial technologies out there that I could take advantage of today? So this is where we start looking at what the traditional storage vendors are doing and what some of the new guys on the block are pushing. So obviously, first things first, there's lots of marketing hype out there. So what I like to say is, take everything that you hear with a grain of salt, even what I'm saying. Because what you really want to do is look at what's the best fit for you. In some organizations, you might already have a storage array that has the capability to have flash put into it, and that might be a good starting point for you. Other organizations might feel, right, well, I have a few applications that actually need some dedicated high performance storage requirements, might be best to actually go and get a dedicated array for that, and then start migrating my other workloads onto that new array as we start phasing out some of our old kit. Again, knowing what you need to do and how that fits into the I/O profiles that you have for your applications is really important. It's not about I have the new latest toy and it's Flash. It's how you can best use possibly what you've got right now, so you get the best use out of your existing investment, and what you might be looking for doing in the short or medium term. While the cost of the cost versus performance tipping point hasn't quite reached yet in the flash storage space, we still have concepts of hot and cold data. So what data is being accessed, written to very frequently, needs to have that sub-millisecond level of performance that you get out of flash storage. And what is cold? What's your cold data? And that data should be sitting down potentially on high capacity, low performance drives while you still have that capability within your organization. And that gives you the better use out of what you might currently have. That might not fit what you want to be doing in 12 months' time. So when you start planning your next storage purchase, maybe you want to take a different philosophy around how you handle hot and cold data, depending on what your I/O profile is like. Could you use Flash to augment the cache that you have on your current storage array? That's a particular option that's available to some vendors' storage kits, such as EMC, such as Hitachi, such as HP. They have the ability to actually take some of those flash drives that you have and actually augment the cache that's in the controllers. So you take away the capacity, but actually use it to actually serve IOs directly out of cache. Now that's a good intermediate use, but in the longer term, that's not how you'll be using flash storage anyway. So augmenting cache might be really good if you're using flash drives to retrofit into your existing platform. Can deduplication reduce my storage footprint? So this is where some of the new guys on the block have started a big trend around making full use of deduplication of what's stored on your storage array, so you can reduce the actual physical capacity that's there, therefore you lower your power and cooling costs inside of your data center. So that can be a really good trade-off. You can save on power and cooling and then use that to actually buy the flash storage component, so that you can get the additional performance for your applications, but also lowering your carbon footprints at the same time, which seems to be a big point in today's data center environments. But there's also one last thing that not a lot of people think about when they look at flash storage environments, and that's your data protection, and especially when it comes to replication. Flash storage is sub-millisecond. It's at silicon speeds, so it's extremely fast. There's quite a few organizations out there that have a legal requirement or a business requirement to replicate their storage to a DR facility. And those sorts of legal requirements would, for example, in a financial institution sense, they need to make sure that every transaction that's written to their storage array in their production site is immediately and synchronously replicated to their DR site before that transaction is acknowledged as being written back to the application. When you do that, if you don't have a fast, an extremely fast network pipe between your production and DR facilities, with flash storage, you're going to lose the performance that you get from the silicon speed of your flash memory modules in that storage array, because they're going to be sitting there idling, waiting for the I/O to be transmitted to the DR site and then written to the DR storage array, and then have that acknowledgement come back. So that's something that you need to look at, because a lot of people don't think about that, and then they suddenly realize that they're getting really bad performance from their applications, and they don't know why. And the reason being is that their replication is hurting their storage performance. So that's one thing you do need to look at. It's not necessarily always just looking at the storage array, it's looking at your entire design around data protection and replication to make sure that it can handle the quantum leap in speed that's coming from flash storage. So, traps to avoid. So we've all seen the old Wile E. Coyote cartoons where he comes up with some ingenious plan to actually capture the Roadrunner so he can have a nice meal. Some of them are harebrained schemes, some of them seem quite logical, but the execution is poor. So it's looking at what traps to avoid and where you can actually get a good use out of it. So we'll start with a bit of a use case scenario here. How to get the best out of flash storage. Let's look at an I/O intensive environment. So let's just particularly look at a single use case. So say a big data or a data warehousing environment where they have a relatively static amount of data that gets put in, say, once a day, say stock levels for a supermarket or chain, and then they want to be able to munge all that data so that they can figure out what stock needs to be replenished in each of their supermarket stores so that the trucks can get filled and sent out. So I actually worked on a similar scenario to this in my days in Vendorland, and we worked out a way to be able to do this so that this particular organization could not only do it once a day, because that running those reports for generating the stock would take 16-17 hours to do, how they could run that particular report multiple times a day so that they could keep the trucks rolling around the country in order to make sure that there is stock on the shelves, because if there's an empty shelf, there's no customers, there's no revenue. Stock on shelves needs to be there all the time, and that increases revenue because people will buy things while they're at the supermarket. So let's look at this particular scenario. So obviously there's going to be periods of very high I/O requirement. All right. In order to speed up the processing, you need to be able to have low latency response times from the storage for all the requests that come through to pull data out of these inventory databases so that they can be computed and the data analyzed. Now, given that there's a large portion of relatively static data that only changes on potentially a daily basis when the inventory stock reports come in, the high utilization of write-through caching is potentially a good fit use here. Now, in this case, this was before a lot of the new flash storage players came into the market, so we're looking at a traditional storage array that has separate tiers. So what they were looking at is how much flash storage should they put in here in order and add a portion of that into the cache to augment the cache of the controllers in order to provide predictable read-ahead caching that the controllers could see, suck up the data that needs to be there so it could actually be read out of the actual cache. And that provided an immense boost in performance. So that 16-17 hours of running that report actually got reduced down to less than 5, so that they could run this these stock reports multiple times a day. But when you're doing these kinds of analysis, you always have to look at optimizing the entire stack. So it's all well and good to look at, hey, I can put a large amount of flash storage sitting at the bottom of the stack and it'll solve all my problems. Not necessarily so. Because all you're really doing is now you're moving the bottleneck away from the storage to somewhere higher up in the infrastructure and application stack. So all of a sudden you might not have enough bandwidth in your fiber channel fabric or in your iSCSI IP network in order to cater for the speeds that are now being generated out of the storage. Your servers might not have enough grunt, so you might need to put more high-powered CPUs, more cores. Your application or your databases might need to be better optimized in order to cater for the silicon speed responses that you're going to be getting out of the storage. The obvious example here is to look at how your databases are indexed and whether or not they're optimized to give you access to that data in the most efficient manner possible. And that could save you 10, 15, 20% performance gains. So, and also understanding where you can actually offload data that's not being accessed. So if you're running these stock, in this particular example, they suck in all the inventory data from all the supermarkets, process it, but they need to hang on to it for historical reasons. But they don't want to keep it in their flash tier. They wanted to move that after it had been processed down the stack into high capacity drives in order to, and then eventually vault them off onto nearline media in order to keep that data for a period of time for historical trending analysis. So there are a number of things that you could do in order to use that environment, make sure you get a real business benefit out of doing the storage with Flash, but also making good use of what you currently have. So that's just one scenario that I've worked on in the past. So, how you deploy it is important. So this is where you come into the scenario of looking at what's best for your organization. So, we've already spoken about a few of these already. The cost versus the benefit. So that tipping point of cost versus performance of flash storage versus spinning metal drives, that's starting to change. So you're going to start seeing more and more flash storage as being the primary disk tier of choice, and over the course of the next few years, as some of the new storage flash storage vendors would love to see, is that spinning metal disk drives will eventually start becoming the old way of doing things. And that's certainly where things are starting to head. So it's good to have an idea of where you're going to be heading. Where does flash storage shine? So obviously it's for very high performance applications right now. But over the course of the next few years, you're going to start seeing a trend towards using flash storage across the board. So that's where technologies such as compression and deduplication can become really important. Knowing your I/O profile. This is, from my perspective, the most important thing from a storage perspective across the board. Understand what you're trying to do, what your applications are trying to achieve, how the business wants to make use of the information that you have, and then you can use that as your criteria for purchasing the right storage for your environment. And we all have to make sure that we keep our jobs nice and secure. So we replicate our data, we protect our data, we back it up. we make sure that we can recover that data. With flash storage, it takes that quantum leap in performance. We also have to look at other aspects of the IT design to make sure that we can still get the best use out of it while still protecting ourselves and keeping the end users happy from having good, fast performance. But there is one little white elephant in the room. And this is what I'm going to finish off with today, is that you may have heard of there's been a lot of fear, uncertainty and doubt, or FUD, that some marketeers will come out with, and that's the actual life cycle or lifespan of flash memory modules. It's known as flash degradation. So I want to go through a little fact or myth session here, just so that you can understand what the concern is and how it's being mitigated under the current designs that are out there. So, what is the flash degradation? Basically, it's wearing out the circuitry within one of the floating gate. Just like any gate you see or door, if you use it too many times, sooner or later the hinge is going to get creaky or something breaks, and then you'll all of a sudden it no longer works. You need to replace it. A flash memory module and that design, same thing. When you change the voltage in a flash memory cell, eventually you'll start wearing out that circuitry. So when flash memory modules first came out, they were treated just like a normal hard drive. And when a normal hard drive reads and writes the same data block within close succession, they basically they don't move the data around. They basically write over the existing sector on that particular disk platter. It's because you've just read it, you're going to write over that piece of data. There's no point moving the heads on within the drive. You may as well, for speed and expedience and performance, just write it over that same space. If you do that with a flash memory cell and you do that in a high write I/O environment, you will wear those out very quickly. So, that caused some concern. How did the designers come around with a different way to handle that? So instead of being able to read and write in 4K blocks, they changed the erase function so that you would have to overwrite a large number of blocks at once. In this case, 64 pages is a one erasable block. So by default, that's around 256K. What this forces the controllers to do is, instead of overwriting the same cells again and again and again and again and again and wearing the circuitry out, it reads that particular block of data and then says, right, well, okay, I'm going to overwrite that, so I will write it somewhere else that isn't inside of that particular block that I could potentially erase. So it moves the wear leveling down, moves the actual data around and shares the load amongst all the memory cells that are inside of that module, and then marks that original block that has just been written somewhere else as old. And then over the course of a particular day, whenever the housekeeping gets run, it will go through and check all the old pages that have been marked and then grab all those blocks that are freed up, erase them, and start streamlining where blocks are written so that you get most effective use out of your storage. So that's done in housekeeping. So most of you would probably know that that concept would be known as defragmenting a hard drive. Basically storage controllers with flash memory modules do that in the background. You don't need to manually do that. So that's the concept of write amplification, where you would be constantly writing to the same 4K page constantly and wearing out the gate. And that's what would be causing most of the flash degradation. So the concept of mitigating that is known as wear leveling, where you would actually take a block of data that you're going to overwrite, write it somewhere else, and then mark that block as old. And then it would be taken care of in the housekeeping. So that's how you should look at your storage arrays and how they would use flash if it's best for your organization. All right. So this is just one way of looking at it. There are a number of different trade-offs depending on, what type of memory cell that you invest in, and that changes depending on which vendor you use. Some of them have a combination of SLC and MLC drives. Others specifically use one type of drive because that's the best for their environment based on the type of technology that they're using. So, if you're looking for advice, you can get a lot of it from all the different vendors. Some of it's good, some of it's not so good, depending on what sort of environment you're trying to look at from a performance and benefit perspective. But it's good to get independent advice. So that's where folks like myself at NTT, we can help you with that. We can give you independent advice based on our expertise and experience because we deal with all the vendors. We take a holistic approach around infrastructure, managed storage, and cloud solutions. So depending on what kind of environment you're looking at, whether it be your own infrastructure or whether you're looking at some kind of managed service or cloud offering, whether it be public, private, or a hybrid version thereof, we can help you. And you can get access to any of our storage experts, myself included, and we can help you plan how you build your technology roadmap going forward. More than happy to sit down with you, have a look at what you're trying to achieve, what your business is trying to do, and help you get the most out of your IT budget for the applications that you're trying to serve for the business. And with that, I'll open up the floor to some questions. You can put questions into the chat box, and I'll be happy to answer them here while we're online. If not, then I thank you for your time today, to spend a little bit of time to hopefully broaden your knowledge around what storage options are available. And if you need any help whatsoever, we're more than happy to take your call and come out and speak to you around what we can help you with on your infrastructure and business needs. So with that, I'll open the floor to any questions and we'll go from there. Alright, there aren't any questions at the moment. More than happy to field any questions offline if you'd like to speak to us directly. More than happy to do that. Thank you for your time today and hope you have a great day. Cheers.